Before we get to the cocktail hour, which is provided by Turner, we'll continue to focus on thinking locally and delivering globally, on international codes and standards, certifications, and regulations. I want to welcome Dennis Julian, one of our subject matter experts and principals here at ID Group.
Should be all set. Should be up and running? Yeah. Okay. Good. All right. Thank you for all persevering. We saved the best for last. Nothing more interesting than a code conversation at the end of a long day. So hopefully you won't fall asleep at least until the second or third slide. So basically what I want to go over is some certifications and talk about some of the issues we run into in dealing with international work and in some of the code compliances and energy codes that we come across. So the biggest thing that we have, or the biggest issue we run into is, what is the goal of the project? What certification does the client require? And depending on where you are, there's different certifications. Uptime has their certification, which is basically a performance-based certification. ICREA has their certification, but it's more prescriptive, in that they tell you what you need to do. TIA ANSI 942 is prescriptive and performance. So it's got a little bit of both elements. And then the ANSI VISCI 002 best practices talks about a list of best practices. There are some matrices and charts in there as to what you should be doing in various levels of reliability. And as Matthew mentioned earlier, China has their own set of requirements. They have an ABC data center requirement. So we need to know what each one of those are and how it's going to apply to your project. Uptime does various certifications. They're international. They're pushing more into other countries to push out a reliability matrix that they like to use. They're basically a power and cooling requirement. So they want to make sure that the power and cooling is a tier level that we're expecting in that facility. Everything else is important, but not really part of their standard. So they have a performance-based standard. It's concurrently maintainable or it's fault tolerant. And how you get there, they don't really care. At the end, they do the testing and verify that you actually got there. So from a designer standpoint, it's really open. You have a lot of opportunities to meet that requirement in innovative ways. Their tiers are 1 through 4. With the various levels of availability, up to tier 4, which is 99.99%. They only have a few basic requirements. One is 12 hours of fuel, and that doesn't matter if you're tier 3 or tier 4. That's all they require. Generally, clients want more than that, but that's all that they require in their specification. And then if you go to tier 4, they're looking for compartmentalization as well as continuous cooling. Other than that, you're just going to be concurrently maintainable or fault tolerant, and you decide how you're going to meet that requirement. They do have certifications. They will come in and certify both your design and your construction. The design certification is only good for 2 years, and then you have to recertify. And if you get construction certification, that's good until you modify the construction. ICREA is another fast-growing requirement. It was started in Mexico. But they were also in 21 countries, and they've got 1,300 members, and so they're pretty widespread. You see them more and more. They're very much a prescriptive requirement. They're not as mature, I think, as the Uptime Institute requirements are, but they do have a long list of things that they're looking for, and they also have an extra level. They go a level beyond 4. They go actually to level 5, which has some additional reliability and redundancy built into it. They also have a certification program. Well, they will come out and certify you. They're a little bit negotiable, as is Uptime, but it's a little bit more difficult with ICREA because they are prescriptive rather than just strictly functional. And their level 5 actually has an extra layer of redundancy. It's up to 9.999 versus 9.9, which is what the Uptime Institute uses. TIA ANSI 942 is another standard that's out there. This is one that is an ANSI standard as well as a TIA standard. We see this a lot in government specifications and also overseas specifications. It's nice and easy. It's a matrix. It's a checklist. It makes it very easy to say, you've got to have this, 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 and this to meet this tier. The problem that you sometimes run into is it asks for requirements that don't apply to your project. One example is they have a requirement for structural passive dampers and isolation bases on a Tier 3 design. Regardless of where you are, you're in a seismic area or not in a seismic area, they have that requirement. It's a checklist requirement. So unless you're in California or in a high seismic area, you don't see that requirement. So an existing building won't have it. And if you build a new building and you put that in, it's an expense that has to go into the project to meet that requirement. So they're a little bit more, because they're so prescriptive and they try to cover so many different options, it makes it a little bit more difficult to meet their requirements. But it is a nice little checklist format that they work. They have started an association with EPI to do third-party certifications. So you could get it certified as a TIA 942 certified facility. They only have 4. They originally were following the Uptime Institute tier levels. They've had a falling out with Uptime with the terminology. They are now levels. They are also associated with the next one, which is the BICSI. I assume that in the next go-round of TIA, they will change just their rating systems to F1, 2, 3, 4, which is the rating system that BICSI uses. BICSI is really a best practices manual. It does have a matrix for the electrical systems. The other systems, it just talks about recommended practices for the various tier levels and reliability levels that you might be approaching. And they go from F0 to F4. F0 is basically an office space. F4 is really one step above above the Uptime Institute level 4, tier 4. So it gets a little confusing there because their F4 is really more the equivalent of ICREA's level 5. But that's what it is. Operations is another certification that Uptime has come up with. So rather than the reliability, they don't touch all the other issues. To deal with that, they've come up with an operations requirement, which they can be gold or bronze or silver. And they go the extra step for a tier 3 rating with Uptime. You can get away with that by using one UPS power path and one non-UPS power path. And that meets their requirement. We don't see that very often, but that does meet their tier level. This operational requirement, if you put in 2 UPS paths to your equipment, you get a higher tier level operations, so you get a tier 3 gold versus a tier 3 silver. It works, that's the way they work it. Sustainability, energy efficiency, again, that's something that varies across the world. Here we talk a lot about LEED, but there's LEED, there's Neighbors in Australia, there's BREEAM in Europe. You get the US EPA Energy Star, Japan has a program, Taiwan has a program. Green Globes is a program that started in Canada, that's also you see in the US. Fit for Green is an EU consortium. CETA is another UK company that falls, and Singapore has one. So we need to find out at the beginning of a project, what are your goals? And each one of them has their own way of satisfying their requirements. So the regulations and the standards, they vary by country. We may follow IBC International Code, mainly in the US and in many other countries. Nfpa is commonly cited across the world. ANSI, IEC, and ISO, those vary. ANSI is more US standard, IEC and ISO are more European. The same thing with UL. There's British standards, which is generally electrical. That is different than the National Electrical Code, which is used in many locations. So the way that those work really varies from location to location. We show on the right is a picture with some cable tray with conductors in it, as was mentioned earlier. That's a very common design in other countries. That's a British standard requirement. They don't use conduit very often. Whereas in NFPA 70, which is National Electrical Code, we tend to use conduit all over the place. So it really makes a difference in your designs and how you approach them depending on what they're going to follow for standards. The professional record versus the AHJ versus a DRO in Mexico is how or who is responsible for a project. In the US and many other countries, we are responsible as the professional record, and so we have to certify that the drawings are correct. In other locations, it's more the AHJ, or it may even be a separate independent authority like the DRO in Mexico. Nfpa 70 is a national electrical code. It's cited by many states and many countries, but it is different than the British standards and how they design. On the right is two pictures. One is a utility tunnel, which is a connection between the generator building and the data center. It's cable trays in a tunnel versus the picture below, which is a typical US design, which would be PVC conduit that's going to get buried in duct banks underground. More cost effective, less of a space issue in a building. But if you follow the British standards and use cable tray, then you end up with building tunnels, and it's a different design philosophy and space requirement in this, as you work. IEC versus ANSI. ANSI is an American standard. We tend to overbuild our equipment in the eyes of IEC. Well, for instance, a motor starter that we would have that would be ANSI rated would be good from 1 to 10 horsepower. In the IEC world, that would be 5 or 6 different starters. They tend not to overbuild. We tend to build tanks. IEC tends not to. So that's another issue you need to be aware of as you go from country to country as to what standard they're following. They're both appropriate when applied appropriately. You just need to know that. Sizes do change and availability changes. National Electrical Code for modulars is starting to, since modular data centers are becoming more popular, the National Electrical Code in the 2013 edition actually put in a requirement for modular data centers. So there's now a code requirement there. UL has also come up with UL 2755, which they will certify a modular data center. So it used to be free-for-all as far as what a data center was and what it was built to. Now there are very specific code requirements, both in the National Electrical Code, which in most local jurisdiction is code, and since there's a UL requirement as well, many places require UL certified devices, so that you would have to get certified as UL as well. Then on the telecommunications side, there's also a multitude of standards. ANSI TIA 942 really started as a communication standard. They then delved into building, so it gets cited for building as well as communications cabling. And then there's Australian, European, and ISO-EIC requirements as well. Codes and the standards affect our designs. That's why it's very important to know what standards we are trying to follow. The 2010 version of 90.1 is an energy code requirement that's specifically called into data centers. It came out in 2010. It's just now becoming a requirement in many states. Federally, it was required as of last October to be the minimum code requirement in all states. And last year, they actually issued the 2013 version, which will take a couple more years before the states start adopting it. And that is even another 10 or 20% more energy efficient than the other standard. But the big key to both of those standards is they specifically talk about data centers. A lot of the exclusions we used to follow have gone away, and they specifically apply to data centers. So we have a lot more air economizer requirements, or at least economizer requirements, not necessarily air. Could be water or some other efficiency requirements that we have to follow. The IECC, the International Energy Conservation Code, the International Green Code, they all invoke the ASHRAE 90.1 code as one of the requirements, so therefore you need to follow those codes as well. And then ASHRAE is also developing a 90.4, which is going to be specific energy code for data centers. That is presently out in draft form and intended to be issued sometime this year. and then that would then obviously impact our data center designs as well. The green grid is the major driver of energy code requirements and data center efficiency in the U.S. They've been working internationally with all the other various forms to try to come up with a standard that everybody could follow, so we could get down to one common requirement. So they've been working, and they just issued this harmonizing global metrics for data center efficiency, so we had common definitions as you go from country to country that we can follow. And there's a whole mouthful of them. There's a lot of them. There's data center energy productivity. There's power usage effectiveness, which we see a lot. Data center efficiency, which is just the inverse of that. Water usage, fixed to variable energy ratio, all trying to address the energy issue. And then we get beyond that, and we get into carbon usage effectiveness. CUE is another metric that is starting to come up. There are many countries that are looking at charging or taxing carbon usage. And as they do that, being more energy efficient will help with our carbon, but they're also looking at carbon beyond your data center. So when we hear about Facebook being brought to task because they're in an area that has coal plants, and they're getting coal plants from the utility, that's being penalized for their facility. And so that's carbon taxes will help increase the cost of that energy and will help encourage them to go to areas that are not using dirty electricity. They're using hydro or wind power or solar or some other such form. There's a variety of countries looking at it. Australian government is actually looking to abolish the carbon tax. They had it in there. They felt it's a drain on their economy. They're actually right now voting on repealing that carbon tax. China was also planning on doing something this last year. They're now reconsidering also removing it from a cost standpoint because the carbon tax is increasing the cost of the electricity. Another efficiency requirement out there is the green energy coefficient, which is a function of how much green energy you're using in your facility. And the energy reuse factors has to do, again, with how much reusable energy or green energy that you have in your facility. So there's a lot of different performance metrics we have to follow. And that's why it's very important at the beginning of the job to understand what it is we're looking to do. I kind of went through this pretty quickly. Codes are boring. We're at the end of the day. Terry was nice enough to take up some of my time. Go a little long. So if there are any questions, we'll get right to the important stuff, and we'll go for drinks.
Anybody have any questions? We do have a few minutes to get questions.
Sure.
The Uptime Institute said that the Tier 4 rating on the generators had to be continuous rated for the Tier 3 and Tier 4, right? And they asked for 12 hours of available fuel. You know where I'm going, right?
Yes.
So if a standby generator is built to operate 24 hours, why they're asking going continuously if they only ask you to have 12 hours of available fuel? I think they should go further and at least ask for full all days of fuel. Why not going into the standby generator, which is less expensive, less size and maintenance, all of that? What do you think about that?
There are some definite conflicts in their requirements, and that is certainly one of them. Their argument is you can always get refueled. Possibly, possibly not, but you know it doesn't seem to go together.
You pay a lot for an autonomous system, right?
Yeah.
To recover by itself, and you are dependent on the refueling.
Right, right. I agree. There's a conflict there. It's not consistent. As far as a continuous rated, they don't require an engine that's rated continuous. That's kind of a misnomer. The way it's, their requirement is you're able to carry your actual load continuously. And so the generator manufacturers are starting to get on board with that. And Cummins and even Caterpillar will give you a letter and saying at the standby rating, you can run it for as long as you need to run it. It's not an issue. And they have been accepting that in lieu of having to take an engine and derate it and call it continuous. So that's something that they've been backing away from. But I agree, that doesn't really agree with that. The other requirement in Tier 4 is continuous cooling. And the continuous cooling requirement is supposed to match your battery requirement. And if you get two end systems, your batteries are basically, because of the nature of batteries, 3 times what you really need. And they want enough cooling for 3 times the time, which again is way on the other side of what they did for generators. So they're not necessarily consistent.
That will be addressed with a proper assessment of the thermal runaway of the data center itself. Because if you are designing a 3 kW rack density in a small data center at 2,000 square feet, you might be able to remove that heat when the generator power up, and then if you're using water, that might not be a problem. But if you are using compressor in 1 minute, when the compressor start back up, it means that you will take 7 minutes to remove the heat, but still, in those 7 minutes, with that amount of load that you have, you haven't reached outside the ASHRAE parameters.
Right, they're the recommended or allowable.
You said that the Upline Institute said that I have to be tier 4 having continuous cooling with that low density. In my thermal runaway assessment or CFD says the opposite.
Well, the advantage of the Uptime Institute approach is it's functional, right? So it's performance. So what you've got to do is convince them that you have continuous cooling within those parameters. They don't really define what those parameters are. I guess you do as the owner. So I'm saying I'm still within the allowable limits of ASHRAE and without having a UPS on my mechanical systems. So that's something you'd have to go through and demonstrate to them. This is why I think it is, and I think they would accept that. Because they don't have a specific requirement. They just have a functional requirement. So they want to perform that way. It might be you're using the slab as a thermal, storage, and you're blowing air across, and it keeps your room cool enough for the 7 minutes or 5 minutes or whatever that time period is you need for your system to get back up to full cooling. That's something you just have to demonstrate to them. The same thing with the generator. So they take the easy way out. So if it's continuous rated, they know it's okay. If you get your UPS system, UPS systems for your mechanical equipment, then they know they're okay. If you do something else, which is allowable, you just need to convince them that that's an acceptable solution. Any other questions? Over to you, Mike.
Thank you, Dennis.